What if I told you there's a star out there, a colossus many times larger than our Sun, with a volume big enough to squeeze 1.2 billion stars the size of our Sun inside? A star so unpredictable, its brightness changes constantly, its shape twisting and contorting in a cosmic dance. The reason for its unusual behavior is the huge star is on the brink of a cataclysmic finale, poised to explode in a spectacular supernova. This is the star Betelgeuse, one of the brightest stars in our night sky, just 640 light-years away. When will Betelgeuse explode, and what secrets are hidden behind its unpredictable behavior? Are we about to witness a massive supernova in our night sky, and are we in danger when this huge star explodes? Betelgeuse, also known as Alpha Orionis, is a red supergiant star located in the constellation Orion. It's one of the largest stars visible to the naked eye and can be found forming the top left shoulder of the hunter Orion. Betelgeuse is approximately 642 light-years away from Earth, making it relatively close in astronomical terms. This star is truly gigantic. To give you an idea of its immense size, if Betelgeuse were placed at the center of our solar system, its surface would extend beyond the orbit of Jupiter, engulfing Mercury, Venus, Earth, Mars, and possibly the asteroid belt. Betelgeuse has a radius about 1,400 times that of our Sun, and a mass roughly 20 times greater. Despite this, it has a much lower density due to its expansive volume. Betelgeuse is part of a class of stars known as supergiants, which are among the most massive and luminous stars in the universe. These stars have short lifespans, burning through their nuclear fuel at an astonishing rate. Betelgeuse is thought to be around 8 to 10 million years old, which is quite young in stellar terms. However, it's already nearing the end of its life cycle. We said previously that Betelgeuse is a red supergiant, meaning that it's now in the last stage of its life. Having exhausted the hydrogen in its core, Betelgeuse is now fusing heavier elements, causing it to expand and cool, which gives it its characteristic red color. This stage is brief in stellar terms, lasting only a few million years before the star's dramatic demise. The life of Betelgeuse has been one of constant change. It started as a hot blue giant, burning hydrogen in its core. As the hydrogen was depleted, the core contracted and heated up, igniting helium fusion. This process caused the outer layers of the star to expand and cool, transforming it into the red supergiant we see today. The intense fusion reactions in Betelgeuse's core are producing elements like carbon, oxygen, and eventually heavier elements like silicon and iron. Once iron accumulates in the core, it marks the end of the fusion process, as iron fusion consumes more energy than it releases, leading to the star's inevitable collapse. In late 2019, Betelgeuse began to exhibit unusual behavior. Astronomers noticed that it was dimming significantly, a phenomenon that continued into early 2020. This dimming was so pronounced that Betelgeuse's brightness dropped to about 40% of its usual luminosity, making it noticeably fainter to the naked eye. The sudden dimming of Betelgeuse sparked a flurry of scientific activity and public speculation. Many wondered if this was a sign that Betelgeuse was about to go supernova. However, while this dimming was unusual, it wasn't necessarily an immediate precursor to a supernova. Scientists proposed several theories to explain the dimming, including massive ejections of gas and dust from the star's surface and large star spots, akin to the sunspots we see on our own sun, but on a much grander scale. One of the most compelling explanations came from observations using the Very Large Telescope in Chile, which suggested that the dimming was caused by a giant cloud of dust that was ejected from Betelgeuse's surface. This dust cloud, when viewed from Earth, blocked a significant portion of the star's light, leading to the observed dimming. Fast forward to today, and Betelgeuse is once again making headlines. Recent observations indicate that the star is dimming once more. This has reignited discussions and research into what is happening with this colossal star. The recurrence of dimming events suggests that Betelgeuse is experiencing significant convective activity in its outer layers, which may be causing these variations in brightness. These dimming episodes provide a rare opportunity to study the processes occurring in the outer layers of a red supergiant. Scientists are using a variety of instruments, including ground-based telescopes and space observatories, to monitor Betelgeuse and gather data that can help unravel the mysteries of its behavior. Betelgeuse has been observed for centuries, and its brightness variations have been noted by many cultures. Ancient astronomers, including Greeks and Arabic scholars, documented Betelgeuse and its prominent position in the sky. Its name itself has roots in Arabic, derived from Yad al-Jayza, which means the hand of Orion. In literature and mythology, Betelgeuse has been a source of inspiration and intrigue. It's appeared in works of science fiction, such as Douglas Adams' The Hitchhiker's Guide to the Galaxy, where it's the home star of the Betelgeusians. Its prominence in the night sky has made it a symbol of mystery and power. But the question on everyone's mind now is, when will Betelgeuse go supernova? Predicting the exact timing of such an event is extremely challenging. It could happen tomorrow, or it could be another 100,000 years before Betelgeuse reaches the end of its life. What we do know is that as a red supergiant, Betelgeuse is nearing the end of its stellar life cycle. When Betelgeuse does go supernova, it will be a spectacular event. The explosion will be so bright that it will be visible during the day for weeks, possibly even months. It will outshine the full moon and be visible to the naked eye from Earth. This supernova will release an immense amount of energy, briefly outshining the entire galaxy before fading away. The process of a supernova is a complex and violent event. It begins with the core collapse, which happens in a fraction of a second. The outer layers of the star fall inward at speeds of up to 43,000 miles per second, generating a shock wave that propagates outward. This shock wave heats the surrounding material, causing it to glow brightly and creating the supernova's characteristic light curve. From Earth, astronomers will have a unique opportunity to study the supernova in real time, gaining insights into the processes that govern stellar evolution and death. This will also be a momentous event for amateur astronomers and skywatchers, providing a once-in-a-lifetime spectacle. That's if it happens in our lifetime. While we can't predict exactly when Betelgeuse will go supernova, astronomers are prepared to observe and study the event when it happens. Advanced telescopes and observatories around the world are ready to capture data across multiple wavelengths, from visible light to gamma rays. Public outreach and education efforts are also in place to inform and engage the public when the supernova occurs. Organizations like NASA and the European Space Agency have plans to share real-time updates and observations with the public, making this a global event that will unite people in awe and wonder. Technological advances have significantly enhanced our ability to study stars like Betelgeuse. Instruments like the Hubble Space Telescope, the Very Large Telescope, and the James Webb Space Telescope will provide unprecedented views of these distant giants. And if Betelgeuse does explode soon, the images that these telescopes are going to take will be mind-blowing. Currently, these telescopes allow scientists to analyze the light from Betelgeuse in exquisite detail, revealing its composition, surface activity, and internal processes. Future space missions and observatories will further our understanding of red supergiants and supernovae. Projects like the Vera C. Rubin Observatory and the European Extremely Large Telescope are poised to make groundbreaking discoveries, potentially uncovering new insights into the life cycles of stars and the dynamics of supernova explosions. Many of you at this point might be wondering, if the star does explode, are we any danger here on Earth? It goes without saying that when Betelgeuse does eventually go supernova, it will be an extraordinary event for observers on Earth. But the light from the explosion will take approximately 642 years to reach us, meaning we will witness an event that's happened centuries ago. The supernova will be bright enough to be visible during the day and at night. It will cast shadows. Yes, this does mean that the star could have already gone supernova, but we just haven't seen it yet. But not to worry. Despite the dramatic display, Betelgeuse's supernova poses no threat to Earth. The explosion will be too far away to have any harmful effects on our planet. Instead, it will provide a unique opportunity to study the aftermath of a supernova up close and personal. Betelgeuse, the mighty red supergiant, continues to captivate us with its size, brightness, and unpredictable behavior. Its recent dimming episodes have reminded us of the dynamic and ever-changing nature of the universe. While we may not know exactly when Betelgeuse will go supernova, we do know that it will be an event of unparalleled brilliance and scientific importance. So keep your eyes on the night sky, and remember that every twinkle of Betelgeuse brings us closer to witnessing one of the universe's most awe-inspiring phenomena. Until then, we'll continue to marvel at this giant star and the mysteries it holds. Thank you for joining us on this journey through the cosmos. Make sure to stay tuned here for more exciting and mysterious things happening in the universe. And if you enjoyed the video, then give us a like. It really helps us out so we can create more amazing content for our viewers.